Now we're going to take a look at an example of actually factoring a matrix and its inverse using elementary matrices. So we kind of developed the idea, the theory behind this process in the previous video. Now you'll see what it looks like with a specific example. Let's start with our matrix. Let's say we have so I'll do a 2 by 2 matrix. Let's say it's 3, 8, 2, 5. Now, in order to find the special elementary matrices, we can't rely on using our formula. So that formula is like a shortcut, and it circumvents all the steps that are needed in the elimination. So we do have to go through and do our procedure using the Gauss-Jordan elimination. So let's set up our double augmented matrix, and then we're going to go through and for each operation that we use to convert the left-hand side into the identity, we're going to keep track of the corresponding elementary matrix that would perform that operation. So first we need to do 1/3 times row 1, so we get a pivot in our upper left position there. So that means our first row becomes 1, 8/3, 1/3, and 0, and then the second row stays the same. Okay. Now let's write down, and this is something we didn't do previously, let's write down the elementary matrix that is associated with this operation. And the way you get that elementary matrix is by performing this operation on the 2 by 2 identity. Now, since we started with the 2 by 2 identity, that elementary matrix, its elements are right here, right? So we don't even have to think too much about this one. It's 1/3, 0, 0, 1. Now, as we go through, let's say we eliminate this positive 2 by using this operation, -2 times row 1 plus row 2. That means our first row stays the same. And now our second row becomes 0, and then -1/3, and -2/3, and 1, right? So now let's write down the elementary matrix that corresponds to this operation. Now it's not this one here. This is the result of performing these two operations on the identity. So what we have to do is kind of, think back to what the 2 by 2 identity is, perform this operation with it, and then you'll see that E2 is the elementary matrix 1, 0, -2, 1, right? And that's essentially what we're going to do. Every time we do a row operation, we're going to write down the corresponding elementary matrix until we have converted the left-hand side into the 2 by 2 identity. And then we will have all the factors that we need, right? So let's see, we need to have our pivot of 1 here. So if we take -3 times row 2, that produces 0, and then a 1, and then a 2, and a -3. And then the first row stays the same, right, like that. So now let's write down our third elementary matrix. So take the 2 by 2 identity and perform this operation with it, or on it. So E3 is 1, 0, 0, -3, right? So one more operation, and then we will have our identity matrix on the left, and then we will have the inverse on the right, and then we're going to have our sequence of elementary row operations. So lots of information once we complete this. Now to eliminate the 8/3, we're going to do -8/3 times row 2 added to row 1. And then we know that will give us the identity on this side. And then the inverse here, well, here's our second row. And then the first row becomes, so let's see, this is -5, and then a +8. There we go, right? So that's the inverse. And if we were to double check this with our formula for the 2 by 2 inverse, we would see that it's correct. And then E4, again, performing this operation on the 2 by 2 identity will produce this elementary matrix. So 1, -8/3, 0, 1. Right? So what does this mean? Well, let me write down the inverse of these matrices first, these elementary matrices, right? So E1 inverse is equal to, so we have to ask ourselves, how would we undo this operation, right? Well, think about it this way. If I wanted to turn this matrix back into the identity matrix, I would have to multiply this first row by 3. So that's exactly its inverse, right? So you have to think of the row operation that you need and then perform that one to get the inverse of each of these elementary matrices. And then E2 inverse is going to be 1, 0, and then a positive 2 there, 1, right? This one, E3 inverse, is going to be 1, 0, 0, -1/3. And then finally, E4 inverse is going to be 1, and then this is going to be a positive 8/3, 0, 1. All right, so here are the elementary matrices that converted our original matrix A into the identity, and then here are their inverses. So let me state the formula that we that we derived in the previous video. So we showed that, for instance, A inverse can be written as, and it was in this reverse order, E4, E3, E2, E1. And then we also showed that A, the original matrix, can be written as E1 inverse, E2 inverse, E3 inverse, E4 inverse. So here is the inverse of the original matrix, right? So using our matrices here, so then here is the first factorization, so -5, 8, 2, -3, 2, -3, that's equal to my E4, which is 1, -8/3, 0, 1, times E3, which is 1, 0, 0, -3, times E2, which is 1, 0, -2, 1, and then finally E1, which is our 1/3, 0, 0, 1, right? So that's the factorization of A inverse. The factorization of A, our original matrix, again, which was the 3, 8, 2, 5. So here is A. So 3, 8, 2, 5. Well, now that matrix can be factored as, again, it's essentially the inverse. So just going in this order now, working backwards, E1 inverse is 3, 0, 0, 1. E2 inverse is 1, 0, 2, 1. E3 inverse is 1, 0, 0, -1/3. And then finally, let's get a little bit more room. E4 inverse is 1, 8/3, 0, 1, right? So that's our factorization of matrix A. Now this is not the only way it can be factored. Again, it depends on how you do your elementary operations. But with each operation, we can find an elementary matrix, we can find its inverse, and then using these pairs of equations, one for the inverse, one for the original matrix, the matrix and its inverse can be factored into a product of elementary matrices, right? And this factorization, as I mentioned in the previous video, is very, very important in other areas, not just theoretically, but also in applied areas as well. All right. So hopefully you found that example helpful, and I will see you in the next video.